Hello students, let's discuss topic 4 TCP IP layers 4.17 Edexcel GCSE Computer Science. It's quite a lot to unpack here, so this is worth remembering. You've got TCP IP stands for Transmission Control Protocol / Internet Protocol, and they run on what we call layers. Okay, so we'll look at these different layers and what they are. So we have HTTP, SMTP, which is email and how we get information from web browsers, and we call that the application layer. Okay, so application layer. That's one of them. Then the next we have transport layer, which is TCP, transmission, kind of makes sense to transmit data. And then we have the internet layer, IP. And then we have a link layer as well, which I'll put here. So the link layer will be Ethernet. So these are all the different layers, the stack, if you like, is sometimes referred to as a stack. And it's important that you know what the order is. So they're going to go this way. So we have your device up here, and it's all going to go this way. And eventually these are all going to go up through these layers back up to another device, if we're talking to another device. So what's happening here? What are the roles of each layer? So the application layer selects the most appropriate protocol based on the application. So it could be HTTPS, HTTP, it could be SMTP if it's an email. And the transport layer establishes a connection with the recipient computer. This computer here, that's the recipient. And then what happens is we split data up into little chunks called packets. So I'll use an analogy. So if you've got like a photo, I don't know, a desert island, and then you've got a little sun, a little postcard, right? And you want to send that, then it gets chopped up into little pieces. And it doesn't matter what order the pieces go in, because it's like a jigsaw puzzle. They kind of get rearranged at the end. They know what the order should be. So as long as all the pieces get over to the other side, it can be rearranged. So these are all split into packets of data. Well, we've got data packets. All right. And the packets are given a number. So 1, 2, 3, 4. This could be 1 of 12, right? Packet 1 of 12. Before they're passed on to the internet layer. Any lost packets are resent. So if this packet never got to its destination, it can get resent. 11 of 12 never got through, so we can say, okay, look, we need to send that again. So the transport layer also reassembles any packets received into the right order. So that's all happening from this transport layer. It sort of rearranges the jigsaw puzzle of that file. The internet layer packages or unpackages data, adds a destination IP address, so the address, and routes the packet to the next router. Okay. The link layer is the physical hardware connection between the network nodes, and this will use something called a MAC address, and it's nothing to do with Apple Mac. It's just to do with a unique identifier that computers have. What do Apple call it? Wi-Fi something? It's just something weird. But every device will have a unique MAC address attached to it. So you'll always, beyond having an IP address, it will be a unique number for that particular device. So if you had 100 iPods, they're all going to have different MAC addresses, like hard built into the system. So that's the sort of dealing with the physical part. And then NICs, network interface cards, might also be working at this point to identify specific devices. So I know that's a bit of a mouthful. Let's have a look at some questions. So to complete the diagram, so this is where the order is important. Like, we want to be confident that we know the order. So the application is the first one, and then the transport. So just think about when you're using a computer, like you open up your computer, you go to, I don't know, Edge or Safari, right? That's an application, isn't it? So the application is what we're using. And then we have to find a way to sort of transport it across, don't we? So it's like, step one, if you like, going to the application. And then we need to figure out the way of transporting it. And then we have to figure out where to route it to. And then we need to figure out what's the actual hardware that we need to send it to. So you get I think if you put these in the wrong order, you still get a mark, but if you get both of them in the correct order, you get 2 marks. Different protocols, and there's a 4-layer TCP. Okay, so let's have a look. So application, what's the protocol? Well, HTTP, HTTPS could be in there. It could be SMTP for emails, for example, but it could also be like FTP, POP3, the IMAP. It could be all of these protocols, right? I would go with HTTP as the answer, but all of those are correct. Then transport. This is important, so we need to know the layer. Internet, and then the link. And Ethernet's fine, and then internet IP. Okay, internet protocol, the address. This is like the hardware section. This is to do with the hardware. This is to do with like the routing. The transport is like cutting up that picture, rearranging it, and making sure, hey, have I got all those pieces? Checksum works at the transport layer of the TCP IP. Describe how a checksum is used. Okay, right. So a checksum is applied to identify packets that are being corrupted during transmission. Basically, remember, it's like, oh, I'm going to check what you sent me and what I expected it to be. Remember that picture that we cut up into 12 little bits of my sort of seaside scene, desert almond tree, and like my little postcard. We chopped it up, and it's like, okay, is everything actually there? So a checksum formula is applied to the packet before it leaves the source. So before this picture, let's say it's our packet, or let's look at packet 1 of 12, right? And before we look at that, before it leaves, there's a formula that just is applied to it. The source calculated checksum is added to the header. So these packets, like they contain the information for that part of the image, but they also have a load of metadata in them, which includes what packet number it is, the time it was sent, and so all sorts of other information, like a sequence number, a source address, basically like a postcard essentially. So it might have, for example, destination address, source, error, checking, field, timestamp, sequence, number. So all those things are happening. So a new checksum is compared to the received checksum in the packet header. So all of these are checked. If they don't match, a resend request is issued. So a new checksum is compared to the received checksum in the packet header, because when the receiving computer gets this packet, it applies the same checksum formula, and are all those things there? If they're not, then we're going to say, oh well, I need to can you resend that please? Resend if they're not the same. If checksum formula send receive don't match, resend it. So describe how the link layer works. Well, we already had a little look about the link layer. That's the physical part of it. Okay. The physical part here is when we're working with Ethernet, network, NICs, and the sort of the hardware, if you like. So let's have a look at this one. State 2 other items found in a packet. Okay, so I've just covered loads of those up in that other question. So any of these are going to go into that question there. So let's have a look at this question then. Describe how the link layer of the TCP IP stack works. So the best thing here would be to say it converts data into suitable signal for transmission on Ethernet or Wi-Fi. Okay, that's one thing it will do. It will add, let's say, unique MAC address. Every device has a MAC address baked in for source, destination. You could also say receives data from the network, to send to physical hardware. To send to physical hardware. So the important thing here is to tell the examiner that you understand the linked layer is to do with hardware. And if you stick, I think, Ethernet in there, that's a good one. Converts the data into a suitable conduit or signal for that medium. So that was a pretty big one. Remember the order of what these things of the stack, because it will very likely come up.